Hi, AB Calculus students. Here we're looking at the problem AB 2007, number 2. Okay? And in this problem, they've given us an equation f of t, and they're calling this, I'm calling this ET, the entering rate, the rate that things are entering. And here we have g of t, this is the leaving rate. So you'll notice it's leaving at a rate of 2,500. For a little while, and then leaving at a rate, not 2,500, 250, and then leaving at a rate of 2,000. So you can see it's down at 250, and then here it's up at 2,000. So the straight lines, those are g of t, and f of t is this curve graph. Okay, so part A says how many gallons of water entered the tank from time 0 to 7. Well, the area underneath the entering rate, so the area underneath the entering rate will tell you how much entered. That's what the entering rate does. So area underneath the entering rate tells you how much entered. You would just write this out and type it into your calculator. Now, you can use hotkeys if you want to, but here you get 8264. It does say round to the nearest gallon, so I didn't keep the decimals. That is the nearest gallon. Now remember, instead of this, from 0 to 7, I mean, if you want, you can write the whole equation here as well. Don't forget your DTs. Either way, you get the same answer. And that's part A. Area underneath the entering rate tells you how much entered. Alright, so here for part B it says for time 0 to 7 find the intervals when the amount of water in the tank is decreasing. Alright, so quick review. ET, entering rate, LT, leaving rate. When the entering rate is greater than the leaving rate. So we got our cup. Oh my gosh, I gotta go find my cup again. That's so good for examples. Alright, here's my cup. Cup O entering rate. When my entering rate is bigger than my leaving rate, I'm pouring things in faster than it can leak out. So if I pour stuff in faster than it can leak out, the amount increases. Now, when this switches over, and the leaving rate is greater than the entering rate, so things are leaking out faster than I can pour it in. If things leak out faster than I can pour in, the amount decreases. So here the amount increases, and here decreases. And this is what we want. We want to know when is it decreasing. Now, visually you can use the graph to see when the leaving rate is greater than the entering rate. So let's go ahead and look at the graph. This is the leaving rate. So do you see right here in this whole section, the leaving rate is the straight line. The leaving rate is above the entering rate. So the leaving rate is higher than the entering rate. The amount is decreasing. And then it switches. The entering is higher than the leaving, but now look up here again. In this section, the leaving rate is again higher than the entering rate. So from time 0 to question mark right here, we need to know when they intersect. From 0 to this time, the leaving rate's bigger than the entering rate, the amount's decreasing. And then again, starting at 3. So right here at 3 to whatever this time is. So how are we going to find these two intersection points? Well, you have a graphing calculator. So what you're going to do is you're going to plug this in Y1, and then I would just plug 250 in Y2. Change your window. The window needs to go up to 250 and just over to 7. And then you're going to hit intersect right here. And when you hit intersect right here, you're going to get the number 1.617. So this number right here where they intersect is 1.617. Give me 4 after the decimal. Okay? And then the second point over here, we need to know where they intersect. Ends up being 5.076. Okay, so the leaving rate was higher than the entering rate from 0 to 1.617, and then from 3 to this 5.076. So again, I would say the amount's decreasing from 0 to 1.617, and from 3 to 5.076. And that's part B. Alright, now let's go to part C. And this is worth 5 out of the 9 points. For what time t is the amount of water at its greatest? Okay. Now, let's go ahead and look at what was happening. Let's just make a quick timeline for the water amount. So, at time equals 0, if you read the question, at time equals 0, how much water did they say there was? At time equals 0, they said we started with 5,000. That's how many gallons of water. Okay? And I'm just going to make a quick little graph. Okay? So here is 5,000 at time equals 0. Okay. Now, we said from time 0 to 1.617, the leaving rate was greater than the entering rate, so the amount's going to go down. So 1.617, it's going down. And then from 1.617 to 3, this one was higher than this one. All right, can you see how they switched which one was higher? So it's going to increase until 3. Now we don't know how high it got, but it increased. And then from 3 to 5.076, it switches. Meaning the amount's going to decrease. And then finally, from this number here, this 5.076 to 7, the increasing is greater than the decreasing, so it's going to go up. Okay. Okay. So you'll see that there are these 5 points. Now these 5 points, who can win the absolute max or min awards? Endpoints or critical points. So the endpoints are time 0 and 7, and the critical points are where the derivatives were equal. Notice the derivatives were equal, or here because there was a jump, or undefined. So in this problem, they say to the nearest gallon, compute the amount of water basically when the tank was at its greatest. So let's look at when it could have been at its greatest. It could have been at its greatest here, or at here, or at here. So we need to find out how much was at the tank at these 3 times. Those are the only candidates I'm going to worry about. Okay, so I'm going to say time and the amount at some time. And let's just go find these 3 values. How much was there at time 0? How much was there at time 3? How much was there at time 7? Okay, so at time 0 there was 5,000. How are we going to figure out what there was at time 3? Okay. Now this isn't your first rodeo, so we should go back and look at the notes that I've given you for the ETLT questions. The amount at time t is always the initial plus how much you gained minus how much you lost. The area underneath the entering rate is how much entered. The area underneath the leaving rate is how much left. So at time 3, if I want to know how much there is at time 3, well, we need the initial. How much should we start off with? Well, we started off with 5,000 plus how much we gained from time 0 to 3. And here, instead of E of t, I'm going to use F of t. f of t dt, remember this is just this equation here, minus, and we need to know how much we lost from time 3 to 7. Now from, not 3 to 7, I'm so sorry, 0 to 3. So how much we gained from 0 to 3 and how much we lost from 0 to 3. Now, how much we lost from time 0 to 3, we lost 250. Okay. So again, 5,000 plus how much we gained minus how much we lost. And if we type that into the calculator, we get 5,126.591. Okay. And now that we have this, we want to know how much we have at time 7. Well, how much do we have at time 7? Well, at time 7, we don't need to start back here and go all the way. Why start at time 0 when we already have time 3? So, at time 3, I know my initial amount. My initial amount at time 3 is 5,126.591 plus how much did I gain from time 3 to 7? Remember, area underneath the entering rate tells you how much you gained. And then how much did we lose from time 3 to time 7? Now, from time 3 to time 7, it's not 250, it's up here, 2,000. So, we're going to erase that and put 2,000. And now we're going to type all this in the calculator, and we get 4513.3807. Okay. So we said these were the only 3 times when we could have an absolute max. We look at their amounts. The highest one is the maximum. So we would say at time t equals 3, the max was 5,126.591 gallons. And that's it for that question. Thank you for joining in.